Imagine living in the 17th century, a time when all truths were dispensed from on high, not from the stars, but from the throne of the church. The world was described as flat, motionless, with humans at the center of the universe. And if anyone dared to question that, they wouldn't just be criticized. They could be condemned as a heretic. But in the midst of that era, there was one man who dared to do the most insane thing: look up at the sky and believe what he saw. He didn't trust sermons. He didn't trust ancient texts. He believed in the truth as seen through his own lens. When Galileo Galilei peered through the telescope he had refined with his own hands, he didn't just see a rugged moon, much like the Earth, or moons orbiting Jupiter, or Venus going through phases like our moon. He saw an entirely new world, a universe where humans were no longer at the center. And he chose the hardest path of all, to speak the truth. Not because he wanted to rebel, but because he believed in something simple. Truth does not depend on the majority. It remains true even if only one person believes it. Galileo wasn't just a scientist. He was the first to prove that science cannot be imprisoned, that the light of knowledge, even faint, can still pierce through centuries of darkness. This is the story of Galileo Galilei, hailed as the father of modern science. A man who turned a tiny round tube into a tool that challenged the entire cosmic order and paved the way for the scientific revolution. Galileo Galilei was born on February 15, 1564, in the city of Pisa, in the Grand Duchy of Tuscany, now the Republic of Italy. When you hear words like gravity, experiment, or solar system, you probably think of Newton, Einstein, or modern scientists. But to reach the foundation of modern science, humanity owes a debt to a man who lived over 400 years ago, a man who challenged ancient beliefs with his eyes, his reason, and his courage. Galileo Galilei. Mention Galileo, and people often think of him as the inventor of the telescope, the observer of Jupiter's moons, or the man condemned by the Catholic Church for supporting the heliocentric model. But if that's all you know, you're missing the essence of his legacy. Galileo didn't just uncover new truths, he was the first to practice science in a truly modern way, based on experimentation, observation, verification, and logical reasoning, rather than simply believing what ancient philosophers had written. In an era when most knowledge was considered immutable, meaning one had to accept what Aristotle, Ptolemy, or the Bible declared, Galileo dared to say, look, measure, experiment, and think again. When one perspective changed the entire universe. Before Galileo, people believed the Earth stood still and all celestial bodies revolved around it. The heavens were considered sacred and perfect, filled with immutable stars and a smooth, flawless moon. But through his homemade telescope, Galileo saw something else. The moon had mountains and craters, just like Earth. Jupiter had its own orbiting moons. Not everything revolved around Earth. Venus exhibited phases like the moon, a strong indication that it orbited the sun. These discoveries weren't just driven by curiosity. They were pieces of evidence that shattered an entire belief system rooted in ancient thought and religious doctrine for thousands of years. The man who paved the way for the scientific method. Galileo was the first to systematize the experimental method, a scientific approach we now take for granted. Ask a question, observe reality, form a hypothesis, design an experiment, measure and verify, conclude based on data. In his studies of motion, Galileo didn't just theorize, he experimented on inclined planes, used water clocks to measure time, and discovered that the rate at which objects fall doesn't depend on their mass. This laid the groundwork for Newton's later laws. Why was he condemned? The tragedy of Galileo lies not in being wrong, but in being right. Too early. When he published his astronomical observations, Galileo supported Copernicus's heliocentric model, placing the sun at the center and Earth as just another orbiting planet. This directly contradicted the Church's doctrine at the time, which based on the Bible asserted that Earth was the center of all creation. Though the Church initially responded with caution, by 1633 Galileo was summoned by the Inquisition, forced to recant his views, and sentenced to house arrest for life. It is bitterly ironic that someone who used reason and evidence to uncover the truth was silenced by power and dogma, a legacy beyond time. Today, every scientist from physicists to doctors, from cosmologists to AI researchers, works by the principles Galileo established. Not because he was the first to be curious, but because he was the first to transform curiosity into a systematic methodology. Not everyone who looks up at the sky becomes an astronomer, but anyone who questions and verifies what they learn is walking in Galileo's footsteps. Eppur si muove. And yet, it moves. That legendary phrase, though possibly apocryphal, embodies Galileo's unyielding spirit. He knew the sun didn't orbit the Earth, even though he was forced to say otherwise. But the truth doesn't change just because you close your eyes. Galileo lived in a world that wouldn't allow him to see far, yet he chose to look up anyway. And because of him, humanity learned to lift its head and saw a universe far grander than we ever imagined. Imagine living in the 15th or 16th century in Europe. Every day, you went to church and heard priests preach that the Earth was the center of the universe, created by God, and that all celestial motion reflected his divine will. You weren't allowed to doubt it, not because there was no scientific reason to doubt itself was blasphemy. At that time, science and religion weren't two separate streams, they were one and the same, and interpretation belonged solely to the Church. The Catholic Church and its absolute authority. Since the Middle Ages, the Roman Catholic Church held supreme power not only over religion, but over knowledge, morality, and politics. The great universities of Europe, Bologna, Paris, Oxford, were either sponsored or supervised by the Church. Books were copied by hand, mostly in Latin. What people knew about the universe, physics, biology, was based on ancient texts, especially the philosophy of Aristotle and the cosmology of Ptolemy, approved by the Church. According to Ptolemy's model, Earth was motionless at the center. The moon, sun, planets, and stars orbited Earth. Celestial bodies moved in perfect circles, as circles were seen as the most perfect form. This perfectly aligned with theological belief. Humanity was the center of creation, and the universe existed for and around us. Knowledge was faith, not discovery. A striking consequence of this theologization of knowledge and intellectualization of faith was that Western academia stagnated for centuries. If Aristotle said that heavier objects fall faster, that was accepted as truth, even if no one ever tested it. If Ptolemy claimed the universe had 55 rotating celestial spheres, that was copied into books, taught in lectures, and painted on cathedral ceilings. Experimentation was discouraged because it might conflict with Scripture. It implied humans could verify God's words. It threatened the Church's monopoly on knowledge. Knowledge wasn't to be sought. It was to be received. Students were taught to believe, not to question. The revival of thought, from the Renaissance to Copernicus. Then a new breeze began to sweep across Europe. The Renaissance, a period that celebrated humanity, art, science, and reason. People began to retranslate ancient Greek texts, to study once more the philosophies of Plato, Euclid, and Archimedes. Artists no longer painted only God, they painted the human body with anatomical precision. Architects no longer built solely for cathedrals, they started calculating proportions, force, and light. In this spirit, a Polish priest named Nicholas Copernicus quietly proposed a bold hypothesis. Earth is not the center of the universe. The sun is. His work, De Revolutionibus Orbium Coelestium, on the revolutions of the heavenly spheres, published in 1543, the year he died, laid the foundation for the heliocentric model, though it remained more of a mathematical theory than an empirical one at the time. Copernicus was not tried, but Galileo might be. Although Copernicus's model emerged nearly a century before Galileo, it never gained widespread acceptance because it lacked experimental evidence. It was too abstract, and most importantly, it was not allowed to be taught as truth. Clergy, bishops, and even astronomers of the time continued to support geocentrism because it was safe and orthodox. So by the early 17th century, despite the Renaissance sweeping through Italy, France, the Netherlands, and beyond, science had not yet broken free from the shadow of the church. Everything still needed approval. Every new idea still required permission. And truth still had to be obedient. When Galileo entered the scene, when Galileo began his astronomical studies and published his observations, he faced an entire intellectual system wrapped in religious power. It wasn't just a battle between two models of the cosmos, it was a clash of ideologies between emerging science and an entrenched conservative order. Galileo wasn't just a scientist. He became the embodiment of someone who dared to question so-called absolute truths, who demanded evidence over belief, and who dared to say that a telescope might illuminate the heavens more clearly than the Bible. Galileo Galilei was born on February 15, 1564, in Pisa, an ancient city in the Grand Duchy of Tuscany, now part of Italy. Pisa is famous for its iconic Leaning Tower, its classical culture, and as a crossroads of religion, academia, and the arts. He was the eldest of 6 children. His father, Vincenzo Galilei, was a musician, composer, and a notable musical thinker of the time. His mother, Giulia Amanati, was a homemaker who managed the household in a financially modest setting. Though not wealthy, Galileo's family possessed something more valuable than money: a liberal education and critical thinking nurtured at home. A father who was a musician and a thinker who went against the grain. Vincenzo Galilei was not just passionate about music, he was also a critic of classical acoustic theory. He authored works refuting the teachings of Aristotle and Pythagoras on sound, something considered audacious at the time. He believed that experiments and the human ear mattered more than textbook theories. This spirit is what Vincenzo passed on to his son. Don't believe something just because someone said it, test it for yourself. It was also Vincenzo who first taught Galileo about music, mathematics, and logical thinking tools Galileo would later apply to astronomy and physics. Galileo's childhood more curious than obedient. From a young age, Galileo stood out. He didn't just obey, he constantly asked questions. Why does the sun rise in the east? Why does an apple fall instead of floating? Why does a musical note sound higher or lower? He enjoyed dismantling things at home: clocks, music boxes, even attempting to rebuild a miniature water wheel from scrap wood. These antics often worried his mother, but his father would smile and say, "He's not destroying, he's learning." Early on, Galileo developed a love for precision. A famous anecdote recounts how he observed a chandelier swinging in a church and used his heartbeat to time its motion, laying the groundwork for his future studies on pendulums. Early education between Latin and the truth. At the time, the standard academic path for bright boys involved Latin, the Bible, Aristotle, and logic. Galileo was sent to study with priests at the Vallombrosa monastery near Florence, a renowned center for theology and scholastic philosophy. However, Galileo soon became skeptical of what was taught, especially when it contradicted observable reality. He was once reprimanded for questioning ancient theories without offering acceptable proof, a common issue in a dogma-controlled society. It was here that Galileo began to internalize critical thinking while outwardly maintaining a diligent student's demeanor. He quickly stood out for his mathematical abilities and memory. Science begins with medicine. At 17, following his father's wishes, Galileo enrolled at the University of Pisa to study medicine, a prestigious field expected to bring honor and financial security. Yet after only a few months of studying anatomy, pharmacology, and the theory of bodily humors rooted in Hippocratic medicine, Galileo sensed something was wrong. The lectures were formulaic and philosophical rather than empirical. Medicine at the time still blended belief, bloodletting, and superstition. Meanwhile, Galileo became increasingly drawn to mathematics and physics. He often skipped medical lectures to attend math classes. He was especially impressed by the works of Euclid and Archimedes' giants of geometric and experimental thinking. The first step in going against the grain. Not long after, Galileo made the shocking decision to abandon medicine. This meant he had to support himself by tutoring, writing about mathematics, and working as an assistant lecturer. That decision, seemingly reckless, marked a turning point. Galileo chose not the safe path, but the path of truth-seeking in his own way. A mind, shaped by both music and mathematics. What made Galileo special wasn't just that he was good at math. Raised in a musical household, he had a keen sense of rhythm, pattern, and the relationship between sound and number. Later in his studies of oscillation and motion, Galileo applied this dual mindset, seeing with the ear, hearing with the eye, something few of his time could emulate. He represented a complete form of intellect, a scientist steeped in art, a curious child with the discipline of a Greek scholar, preparing for a cognitive explosion. Most geniuses begin with a questioning mind and a parent who believes in difference. Galileo had both. His childhood was not shaped by laboratories, but by endless questions and a hunger to know for sure, rather than just believe blindly. In that household environment, Galileo laid the foundation for the revolutionary ideas he would later develop, from medical student to lover of mathematics. In the 16th century, medicine was one of the most respected and practical professions. For a middle-class family like the Galileis, sending a child to study medicine meant a hope for upward mobility. In 1581, at the age of 17, Galileo officially began his studies at the University of Pisa, one of Europe's oldest centers of learning as a medical student. Intelligent, curious, and earnest, Galileo entered the world of Hippocrates, Galen, and the four humors theory. But after only a few semesters, something started to itch at him. When Galileo began to question. Medical lectures of the time were more philosophical than scientific. Professors repeated the teachings of ancient texts, especially those of Galen, 2nd century AD, without questioning them. For example, if Galen had written that arteries contained air, that was accepted as truth, no matter how illogical. Dissection to challenge such ideas was discouraged. Galileo couldn't accept such unchangeable knowledge. He once asked, "If blood isn't air and arteries pulse with the heartbeat, why do people still believe the opposite?" Instead of copying notes, Galileo spent more time outside lectures, reading mathematics, studying Euclid, and especially Archimedes, the ancient Greek master of geometry and leverage. Discovering his true passion, mathematics. A defining moment came when Galileo accidentally attended a lecture by Ostilio Ricci, a renowned mathematician and student of the master Tartaglia. Ricci didn't talk about simple arithmetic. He spoke about how Archimedes used geometry to calculate volume, describe motion, and determine the center of mass. Galileo was mesmerized. For him, math wasn't just a tool for counting. It was a language that described the world precisely, without the need to believe, only to prove. From then on, Galileo studied ancient problems day and night. He taught himself, took notes, and solved Euclidean theorems applied to real life, measuring the volume of a vase, estimating a tower's height from its shadow, and calculating fall velocity using a pendulum. A decision that changed history. In 1585, Galileo dropped out of medical school without earning a degree, a bold and risky move that shocked his family. In a society that valued prestige and security, abandoning school to pursue mathematics, a field with little economic promise at the time, was radical. But Galileo understood. A meaningful life doesn't have to be safe. It needs to be honest with its own intellect. Years of self-study and financial hardship. After dropping out, Galileo had no scholarship, no academic title, and no institutional support. He made a living by tutoring math privately, taking odd jobs, writing for other scholars, and continuing his research. Despite financial hardship, he never stopped exploring. He wrote his first treatise on hydrostatic balance based on Archimedean principles and began studying falling objects, force, and acceleration. What set Galileo apart? What made Galileo stand out wasn't just intelligence, it was his courage to question the obvious. Why don't heavier objects fall faster than lighter ones? Why must the moon be perfectly smooth? Why does a higher pitch mean a faster vibrating string? Instead of saying, because Aristotle said so, he asked, how can I test that? This was the difference between classical science based on authority and modern science based on evidence. Returning to academia by merit. In 1589, thanks to his mathematical work and Ricci's recommendation, Galileo was appointed professor of mathematics at the University of Pisa. Though a junior position, it marked the start of his official scientific career. He lectured on geometry, mechanics, and sometimes provocatively criticized Aristotle from the podium. There, he conducted his first experiments on falling bodies, inclined planes, and speed, all challenging centuries-old teachings. A step back to leap forward. Galileo's decision to abandon medicine in favor of math and physics was a life-altering turning point. It reflected the most vital trait of his character, the courage to go against the current, to disobey convention, to seek truth. Without that decision, Galileo might have become a fine doctor, but the world would have lost the man who laid the foundation for modern physics. In 1592, after leaving the University of Pisa, Galileo accepted an invitation to teach at the University of Padua, one of the oldest and most progressive universities in Europe, located in the Republic of Venice. At Padua, Galileo became a professor of mathematics, geometry, astronomy, and mechanics, and more importantly, he entered a more open academic environment, less controlled by the church compared to universities under papal jurisdiction. This would become the most brilliant period of his scientific career, lasting nearly 18 years, 1592 to 1610, teaching, lecturing, and building influence. Galileo was a charismatic lecturer, famous for his clear, engaging, and direct teaching style, something rare in his time. He didn't just teach theory. He designed experiments, invited students to observe and discuss. In his classes, geometry was no longer abstract. It was linked to construction, architecture, and levers. Mechanics wasn't based on Aristotle anymore. It involved inclined planes, rolling objects, and pulleys. He also taught astronomy, though cautiously he hadn't yet publicly endorsed Copernicus at this point. The inventor, not just a theorist. Beyond teaching, Galileo stood out for his skill in crafting instruments and designing machines. He didn't conduct research just to write books, he built devices to measure reality. Inventions from this period include the thermoscope, a forerunner of the thermometer, measuring temperature via air volume changes, the compasso geometrico e militare, a multi-purpose, calculating compass used by gunners, engineers, and merchants. Instruments for measuring oscillation time, inclination angles, and center of mass. He once wrote, "Nothing is truly great unless it can be measured." Experiments on motion and gravity. During his time at Padua, Galileo began systematic studies on free fall, force, and acceleration, directly challenging Aristotelian physics. Notable experiments included dropping objects down inclined planes instead of free fall to slow the motion and measure time more easily, using water clocks to time how long it took objects to roll down, recording distances traveled over time, leading to his discovery of the law of free fall. Velocity increases uniformly with time. This achievement brought Galileo closer to the concept of acceleration, laying groundwork for Newton's future laws of motion. Experimental thinking. A new scientific philosophy. Instead of asking, "Why do heavier things fall faster?" Galileo asked, "How can I measure its speed? Can I repeat the result? Is there a formula to describe this motion?" This marked a great intellectual shift from deductive reasoning, Aristotle, to inductive, empirical thinking, the very foundation of modern science. Family and personal life in Padua. Though never married, Galileo lived with Marina Gamba, a Venetian woman, and had 3 children, 2 daughters, 1 son. While he never publicly acknowledged his family, he remained involved and supported them financially. His eldest daughter, Virginia, later became a cloistered nun and kept close contact with her father throughout his life. Their letters are now a valuable historical source, revealing much about Galileo's inner world and private life. Growing influence in academia and politics. During his time in Padua, Galileo gradually became a scientific star. His lectures drew not only students but also nobles, merchants, and scholars from afar. He befriended many notable intellectuals, poets, and engineers. He also began forming ties with the Florentine court, especially the powerful Medici family, a relationship that would become crucial when he eventually left Padua. The beginning of a revolutionary astronomy. By the late 1590s, Galileo had studied astronomy in theory, but still lacked any new observational tools. That changed in 1609, when he heard of a new spyglass invented in the Netherlands, the forerunner of the telescope. He quickly recreated and improved it, increasing its magnification from 3x to 30x, preparing to usher in an era of empirical skywatching. A new Galileo was emerging. His years at Padua marked the birth of Galileo the scientist, no longer just a mathematician or philosopher. Here, he laid the foundations of modern physics, shaped the experimental method, invented new measuring instruments, and prepared to enter a scientific revolution in astronomy. In 1608, in the Netherlands, a lensmaker named Hans Lippershey filed a patent application for a new device, a glass tube that could make distant objects appear closer. The story spread rapidly across Europe. Though the design was rudimentary and the applications limited, many scholars and military leaders grew interested in this spyglass because it could be used to observe enemies from afar. By mid-1609, upon hearing about this invention, Galileo was not only curious, he immediately took action. Not just copying, but revolutionary improvement. With only basic descriptions, Galileo redesigned the spyglass himself. Thanks to his deep understanding of optics and the physics of light, he altered the positions and focal lengths of the lenses, used converging and diverging lenses correctly, improved magnification from 3x to 8x, then to 20x, and finally 30x. Galileo's telescope wasn't just better than the Dutch version, it was the first to clearly observe celestial bodies in history. A historic turning point, observing the sky. By late 1609, Galileo began using his telescope to gaze at the night sky. What he saw changed the course of human history forever. The moon wasn't smooth. Through the telescope, Galileo saw that the moon's surface had craters, mountains, and valleys just like Earth. This shattered Aristotle's belief that heavenly bodies were perfect and unblemished. Thousands of unseen stars, Galileo discovered that the Milky Way was not a faint band of light, but a collection of countless stars. Previously, the human eye could see about 1,000 stars. Now he saw tens of thousands. Jupiter had its own moons. In January 1610, he discovered 4 small stars orbiting Jupiter. After several nights of observation, he confirmed these were satellites orbiting another planet, not Earth. He named them the Medicean stars in honor of the powerful Medici family, his political patrons. The phases of Venus. He observed and recorded that Venus had phases, much like the moon, something that could only be explained if Venus orbited the sun, not Earth. Sidereus Nuncius, the starry messenger. In March 1610, Galileo published Sidereus Nuncius, the starry messenger, the first book in history to describe telescopic astronomical observations. The book caused a sensation across Europe's academic world and made Galileo the face of the scientific revolution, welcomed by the Florentine court. After this success, Galileo was invited by Grand Duke Cosimo II de' Medici to return to Florence as the chief mathematician and philosopher to the Grand Duchy of Tuscany and court scientist. Naming the 4 moons after the Medici wasn't just a tribute, it was a clever strategy to align science with political power, securing Galileo's protection against the conservative forces he would soon face. But dark clouds were gathering. Not everyone celebrated Galileo's discoveries. Many philosophers, clergy, and scholars loyal to Aristotle attacked him. They said things like, "He invented a tool that deceives the eye. The moon's blemishes are caused by a dirty lens. Jupiter has no moons. It's just an illusion." More importantly, supporting Copernicus's heliocentric model was starting to be seen as dangerous, as it contradicted the Bible. One telescope, a whole new universe. Imagine living in 1610, in a world that had believed in a well-ordered universe for 2,000 years. Then one man appears, raises a small glass tube and says, "The world you believe in is wrong. The universe does not revolve around Earth. Earth revolves around the sun." Truth, when magnified, not only becomes clearer, it becomes more dangerous to the old powers. Galileo did not invent the telescope, but he transformed it from a military gadget into a tool of scientific revolution. With it, he overturned ancient views of the cosmos, provided observational evidence for the heliocentric model, opened the age of modern astronomy. Galileo did not merely look, he forced the world to look again at itself. To understand the impact of Galileo's observations, we must first grasp how deeply Aristotle shaped European thought. Aristotle, 384 to 322 BCE, the great Greek philosopher, was the first to develop a logically ordered model of the universe, whose key features included a motionless Earth at the center, celestial bodies, the moon, sun, planets, and stars, moving in perfect circular orbits around Earth, a perfect, eternal, and unchanging heaven, an imperfect, changeable, and mundane Earth. This view was refined by Ptolemy into a complex geometric system and later canonized by the Roman Catholic Church in its theology. Galileo, the first to look at the sky. Truthfully, after building his telescope, Galileo began recording detailed observations. The moon is not perfect. He discovered craters, cliffs, dark and bright regions, clearly a rough surface, just like Earth, not a smooth, flawless sphere as described by Aristotle. The heavens were not perfect. Ancient theory was wrong. The Milky Way and countless stars. Previously, people believed the Milky Way was a fixed, faint, glowing band. Galileo showed that, through a telescope, it was actually tens of thousands of densely packed stars, proving the universe was vastly larger than previously imagined. Conclusion: the heavens are neither immutable nor limited. Venus has phases like the moon. Aristotle and Ptolemy couldn't explain why Venus appeared half-lit, but according to Copernicus, if Venus orbited the sun, we would observe these phases. Galileo proved this. Conclusion: Venus orbits the sun, supporting the heliocentric model. Jupiter has moons orbiting it. If everything was supposed to revolve around Earth, then the existence of little stars orbiting Jupiter was impossible. Galileo tracked these moons night after night and accurately mapped their orbits. Not all motion in the universe revolves around Earth. Reaction from academia and the church. These observations caused an intellectual earthquake and provoked fierce backlash. Many scholastic philosophers claimed Galileo was deceived by his instruments. Conservative clergy asked, "If what he says is true, does that mean the Bible is wrong?" A few progressive clerics quietly read his work and reflected. Still, Galileo's evidence was irrefutable through mere argument or tradition. A shift in thought, from faith to evidence. Galileo didn't just observe the universe, he proved. Aristotle could be wrong, demanded that thinking be based on verification, transformed the telescope into a tool for knowledge, not just a visual toy. He wrote, "Those who refuse to look through the telescope for fear of losing their faith are like those who close their eyes to avoid seeing the sunrise." Long-term consequences. Galileo's discoveries triggered one of the greatest philosophical crises of the Renaissance. Forced scholars to reconsider the entire model of the cosmos, paved the way for Kepler to develop his laws of planetary motion, and later helped Newton build modern celestial mechanics. Conclusion: a revolution from a new way of seeing. Galileo didn't just look up, he forced the world to look inward. He was the first to prove that. The telescope does not deceive, experiments matter more than tradition, and even Aristotle can be wrong. Copernicus and the seeds of revolution. In 1543, Polish astronomer Nicholas Copernicus published De Revolutionibus Orbium Coelestium, on the revolutions of the celestial spheres, which proposed a heliocentric model. The Sun is at the center Earth, and the other planets orbit around it. At the time, this model was viewed mostly as a mathematical hypothesis, not physical truth, partly because there was no observational proof. It contradicted biblical scripture. Most importantly, it opposed the entrenched Aristotle-Ptolemy model, deeply embedded in academia and theology. After his telescopic observations, Galileo realized the phases of Venus. Venus orbits the Sun, the moons of Jupiter. Not everything revolves around Earth. The moon's rough surface and sunspots, celestial bodies are not perfect. All of this supported Copernicus's heliocentric system and disproved Aristotle point by point. From 1610 onward, Galileo openly supported Copernicus, a bold and dangerous move in that era. Why was the Church so concerned about heliocentrism? Because if Earth was not the center of the universe, then humanity was no longer the center of creation. Certain Bible verses would appear incorrect. Most of all, the Church's intellectual authority would be undermined. Many had already paid with their lives for similar ideas, like Giordano Bruno, burned at the stake in 1600 for claiming, "The universe is infinite and contains countless worlds." Galileo's writings in defense of heliocentrism. Galileo didn't stay silent. He began writing, debating, and advocating for Copernicus using both scientific logic and rhetorical skill. Letters on Sunspots, 1613. In this series, he described sunspots, proving that even the sun itself changes, disproving the supposed perfection of celestial objects. Letter to the Grand Duchess Christina, 1615. A landmark letter where he argued, "The Bible teaches how to go to heaven, not how the heavens go." In other words, science and religion need not conflict if each is properly understood. But the world wasn't ready. Despite Galileo's caution, conservative forces struck back. In 1616, the Roman Catholic Church banned the teaching of heliocentrism as truth. Copernicus's work was placed on the Index of Forbidden Books. Galileo was formally warned not to advocate for Copernican theory. However, he was not yet condemned because he had not directly violated the ban. Galileo. Persistent, yet strategic. Despite being officially warned, Galileo continued his research and writing. But he changed his strategy. He presented his ideas in the form of dialogue, used fictional characters, and persuaded readers through observations, not absolute declarations. This approach was fully realized in his upcoming masterpiece, Dialogue Concerning the Two Chief World Systems, 1632, which we'll analyze in detail next. At heart, Galileo was not against religion, but against blindness. Galileo was a Catholic and believed in God, but he also believed, if God gave us reason and senses, he could not possibly want us to ignore the clear evidence he placed before us. A faith in the light of reason. Galileo wasn't merely a supporter of Copernicus. He was the one who transformed Copernican theory into a belief rooted in evidence. In a world darkened by dogma, he held firm to the light of rational inquiry. After the 1616 warning, Galileo stopped publicly endorsing Copernicanism, but he didn't give up. Over the next 15 years, he continued studying celestial motion, carefully wrote manuscripts disguised as philosophical dialogues, tried to obtain legal approval to publish his work. That work became Dialogo sopra I due massimi sistemi del mondo, dialogue concerning the two chief world systems, published in 1632. The book, a lively intellectual debate. Rather than rigid theory, Galileo wrote the book as a dialogue between three fictional characters: Salviati, a brilliant scientist representing Galileo, and Copernicus Simplicio, defender of Aristotle and Ptolemy. His name literally means simpleton. Sagredo, an open-minded intellectual who represents the reader. Across 4 conversations, they discuss Earth's motion, the structure of the cosmos, astronomical observations, inertia, tides, and planetary rotation. The controversy, Simplicio, was too simple. Although Galileo claimed neutrality, it was obvious. Salviati used reason and evidence. Simplicio stubbornly clung to outdated views, often appearing foolish and mocked. Many interpreted this as Galileo ridiculing conservatives. Even Pope Urban VIII, once a friend and patron of Galileo. Urban had requested that Galileo include the idea of God's omnipotence as a possible explanation. Galileo did, but placed those words in Simplicio's mouth, which made the Pope feel publicly insulted. The Church's reaction: no more tolerance. Shortly after the book's release, the Roman Inquisition responded. The book was banned in 1632. Galileo was summoned to appear before the Inquisition in Rome in 1633. He was charged with violating the 1616 injunction and promoting false doctrines contrary to Scripture. This was a pivotal moment. The greatest scientist of his century stood trial before the very institution that claimed authority over truth where reason was not the highest standard. The trial in Rome. At the trial, Galileo argued that the book was merely a theoretical discussion, not a statement of truth, claimed he had obeyed the 1616 order. However, handwritten evidence from 1616 where he had pledged not to support Copernicanism was used against him. Verdict: Galileo was found vehemently suspect of heresy. He was forced to publicly recant his views and sentenced to house arrest for life. Eppur si muove. And yet, it moves. According to legend, though unconfirmed, after reciting his forced confession, Galileo whispered, "Eppur si muove." And yet, it moves. Though he yielded outwardly, he never abandoned the truth. The meaning of the book and the trial dialogue concerning the two chief world systems was the first scientific work to use dialogue as an engaging and accessible format, a final blow to Aristotelian cosmology, a launch pad for modern science grounded in debate, experimentation, and open thought. Galileo's trial became a symbol of the conflict between science and dogma, a historic lesson on freedom of thought, and the reason why later generations called Galileo the father of the modern scientific method. Though banned and silenced, Galileo's words spread. Even though the book was banned and Galileo was under house arrest, copies of his dialogue were secretly passed around Europe. His work influenced René Descartes, Isaac Newton, intellectuals in France, the Netherlands, and England, those who would later lay the foundations for modern science. A single truth in a sea of dogma. Dialogue concerning the two chief world systems was more than just an astronomy book. It was a manifesto for reason, a revolution on paper, and the beginning of Enlightenment thought. Though he was forced into silence, Galileo had planted a seed that no power could uproot. the belief that truth does not depend on permission to speak, only on the ability to prove. House arrest for life. After his 1633 trial, Galileo, then 69 years old, was sentenced to house arrest for life. Though spared the dungeon, he was stripped of the right to travel, lecture, or publish freely. Any future work required strict censorship and approval. Initially, he was confined to the residence of the Archbishop of Siena. Later, he was allowed to return to his modest home in Arcetri, near Florence, where he would spend the rest of his life. A prisoner of thought, surrounded by nature. At Arcetri, Galileo lived in isolation, allowed contact only with a few trusted visitors and disciples. His small, simple house overlooking the hills of Tuscany became a laboratory, study, and his only window to the world. Despite tight restrictions, Galileo never stopped working. A deep bond with his daughter, Virginia, Sister Maria Celeste. In these final years, Galileo's greatest source of emotional strength was his daughter, Sister Maria Celeste, a cloistered nun in a nearby convent. The two exchanged frequent letters. Maria Celeste's writings, filled with affection, wisdom, and care, are now considered a spiritual and historical treasure, revealing the deep bond between an exiled father and his devoted daughter. In 1634, Maria Celeste died of illness. Galileo was devastated, but he continued writing as if keeping the flame alive in darkness. His final masterpiece, a book on motion, Galileo refused to surrender. Although banned from discussing astronomy, he shifted his focus to mechanics and dynamics, fields he had studied since youth. The result was his final great work, Discourses and Mathematical Demonstrations Relating to Two New Sciences, 1638. This book covered freefall acceleration dynamics, material strength. This treatise was the direct foundation for Newton's laws and a cornerstone of classical physics. Because of the ban, Galileo smuggled the manuscript to the Netherlands for publication. The book quickly spread throughout European academia, blind yet enlightened. Despite going completely blind, Galileo's mind remained sharp and luminous. Galileo, blind, but never in darkness. In 1637, Galileo became completely blind due to cataracts. However, he continued working with the help of an assistant who transcribed for him. He maintained written correspondence with foreign scholars. Most importantly, he remained intellectually unshaken until the very end. He once said, "My eyes no longer see the light, but I have seen things that 1,000 blind minds have never dreamed of." Death, but never forgotten. Galileo passed away on January 8, 1642, at the age of 77. Initially, he was denied burial in Santa Croce Basilica, the resting place of Italy's greats, because the church still viewed him as a suspected heretic. Only in 1737 were his remains transferred to Santa Croce, and in 1992, Pope John Paul II formally acknowledged that Galileo had been wrongly condemned, restoring his honor more than 350 years later. Galileo's legacy, from Arcetri to the world. From his isolated home, Galileo left behind a model of science based on experimentation, a methodology of measurement, prediction, verification, a spirit of constructive skepticism, and most importantly, the courage to seek truth despite authority. Theoretical physicist Stephen Hawking once called Galileo the true father of modern science. Lessons from Galileo's final years. Galileo taught us that freedom of thought often comes at a high cost. Truth outlives any regime, and the mind can never be imprisoned, even if the body is Galileo, the founder of physical methodology. When Galileo studied motion, he rejected untested assumptions, established principles based on empirical observation, discovered the law of free fall. Objects accelerate at a constant rate, regardless of mass. He was the first to distinguish mass from weight, describe inertia, that objects stay in motion unless acted upon by force, championed the idea, "I don't trust authority, I measure." These ideas weren't yet a full system of mechanics, but they laid the groundwork that Newton would later build upon. Newton, the man who systematized the universe. Isaac Newton, 1643 to 1727, born just a year after Galileo's death, inherited the foundations laid by Galileo, Kepler, and Descartes. He unified earthly motion and planetary motion under a single framework, formulated the three laws of motion, including inertia, as described by Galileo, force and acceleration, FEEMA, action and reaction, developed the law of universal gravitation, explaining planetary orbits described by Kepler. With Newton, Galileo's ideas became mathematical tools. Newton once wrote, "If I have seen further, it is by standing on the shoulders of giants." Among those giants, Galileo was the closest ancestor in scientific reasoning. Without Galileo's inclined plane experiments, his concepts of inertia and average velocity, his mathematical approach to motion, Newton could not have written the Principia Mathematica, the book that defined the laws of physics for the universe, from Aristotle to Newton. Galileo as the Great Bridge. Characteristic: Aristotle. Galileo. Newton. Cosmology. Geocentric. Supported. Heliocentrism. Heliocentric plus gravity. Method: deductive reasoning. Observation plus experimentation. Mathematics plus modeling. Motion: natural versus forced motion. Inertia. Acceleration. Laws of force and universal motion. Weight, based on nature of object, independent of mass in freefall. Gravitational force equals F mass, distance. Galileo served as the intellectual bridge that led the world from ancient Aristotelian views to modern classical mechanics. An influence beyond his time. Galileo's impact extended far beyond Newton. His mindset shaped the entire European Enlightenment thinkers like Voltaire, Kant, and Laplace, and the scientific method we still use today: hypothesis, prediction, experiment, analysis, repetition. Why couldn't Galileo do Newton's work himself? Because mathematics had not yet advanced to calculus. The concept of force was still vague. Accurate instruments to measure acceleration and time didn't exist. And crucially, he lacked an environment of intellectual freedom. Still, Galileo went further than anyone of his time, and no one else could have gone farther then. If science were a relay race. Aristotle marked the starting line. Galileo broke away from ancient thinking. Newton carried the torch into the cosmos. Galileo didn't complete the race, but thanks to him, the baton of knowledge was passed at the right time, to the right hands, and at the right height. A legacy that outlived suppression. Galileo died in 1642 at Arcetri, near Florence, still under church supervision. He was denied burial among Italy's heroes in Santa Croce because he remained a suspect of heresy. And yet, the academic world never forgot him. Even while banned, his works were secretly printed in the Netherlands, France, and England, taught in free-thinking academies, and deeply influenced later minds like Newton, Huygens, Hooke, and Leibniz. Dialogo, from banned book to beacon of freedom. Though banned in Italy, Dialogo, dialogue concerning the two chief world systems, became a monument of scientific resistance against dogma, a symbol of intellectual freedom, a must-read in Enlightenment-era universities. It was translated into many languages and inspired even democratic movements thanks to its defiance against blind authority. 1737, 95 years after his death, Galileo was reinterred in Santa Croce Basilica in Florence, buried next to Michelangelo, honored with a statue and engraved tombstone. From suspect heretic, he became a cultural hero of Italy, revered as a symbol of intellect. 1992. The Church admits its mistake. After more than 350 years, in 1992, Pope John Paul II officially restored Galileo's honor. Following a church commission that investigated the case for over a decade, the Vatican concluded Galileo had been unfairly tried. He was right to support heliocentrism. The Church must acknowledge its historical error. The Pope declared, Galileo shows us that faith and reason do not conflict if we properly understand the limits of each. It was one of the most important public apologies the Church ever made to science. Today, Galileo is recognized as the father of modern science, the pioneer of the scientific method, one of the greatest physicists of all time, an eternal symbol of free thought, courage, and faith in reason. Galileo's concrete scientific legacy field. Main contributions: mechanics, foundation for Newton and classical physics; astronomy, father of modern astronomical observation; philosophy of science, pioneer of empiricism and experimental philosophy; science education, popularized scientific thinking for the general public; critical thinking, one of the first to challenge authority with evidence, not opinion. His name is engraved across the map of knowledge. The Galilean moons, 4 satellites of Jupiter. NASA's Galileo spacecraft, launched to Jupiter in 1989. Universities, academies, telescopes, streets, monuments all over the world bear his name. Galileo's final message to humanity. If we could distill one message from his entire life, it would be, see with your own eyes. Test with your own reason, and never bow to a truth just because it makes others uncomfortable. Galileo, not just a man, but a turning point in human thought. With Galileo, we stepped into a new age, an age where belief was no longer untouchable. Truth could come from a telescope, not just scripture, and humanity became the seeker, not the blind follower. A complete summary of Galileo. Galilei's life, work field, major contributions: astronomy, telescope, Jupiter's moons; Venus, phases, moon and sun observations; mechanics, free-fall experiments, acceleration, inertia, basic dynamics; modern science, experimental method, measurement, scientific skepticism, philosophy. Refuted Aristotle, fought dogma, laid groundwork for scientific thinking. Society and thought, symbol of intellectual freedom, rational resistance, and overcoming fear of power. Galileo, the light that led science forward. From a boy in Pisa to a global icon, Galileo Galilei showed us truth can be buried, but not destroyed. Science is not just a tool, it's a way of life, and sometimes a single look through a telescope can overturn an entire world.